Bitcoin show. Today is March the 4th. We had a very good day. Bitcoin went up, 20% in a day? What was it?
Well, not quite that much, but we're at 73 right now, round
Yeah,
numbers.
more like 6-7%. So it was a pretty good day. Um, that is actually interesting. After all these talks about price suppression and so on, I don't know if that is actually true or realistic, but who knows? Um, what do you think? Maybe we can discuss for a few minutes about that. Do you believe that this price suppression thing?
Well, I think it's possible in the long term. Sorry,
Uh-huh.
in the short term, but not
For
in the
sure.
long term.
Right.
Yeah, it's in fact, I'm going to talk about long term, intermediate term, and
Uh-huh.
short term nature of things. That's kind of the theme of what I'm going to present today.
Okay. Good. Um, yeah. So, a few announcements. First of all, I want to remind everybody about this new initiative, a Scientific Bitcoin Institute. We are launching some social media initiatives. We are going to have soon a YouTube channel, so you can follow us also on our YouTube channel. There will be different content related to the institute. We are going to have an X account. We are going to announce soon that on Steven's social media, my social media here. So look up for these activities from the Scientific Bitcoin Institute. There will be more things happening with time. Materials that different interesting learning material online on the website. It will be kind of a focus for learning about Bitcoin in general, but also different academic studies about Bitcoin. Um, of course, it's kind of uh, power law oriented, but not just power law. And then another announcement. Uh, My book, The Physics of Bitcoin, is on pre-order on Amazon. I don't know why Steven is having some problems with his connection. He's coming in and out. Um, and yeah, so if you this is you can look it up on Amazon, or you can follow this address and find it online if you want to pre-order it. Steven is back. Let's hope that he stay with us. You having some connection problem?
Yeah, it was flaky, so I switched subnet. I switched over to the router, which is more local than the main one.
Okay,
So,
but now you're
but
getting
I don't know.
frozen.
Something else is going on.
Ah, okay,
Okay, well,
now
let's see.
that's better. Okay, so yeah, and the physics of Bitcoin is going to be actually it's quite a bit of work. It has many pages on the Word version has like 300 pages on Kindle, many more because it's few words per page. Um, but yeah, it's going to cover most of the topics that I have covered over time, like the idea of a power law, but also it gives the foundations. There are chapters on what power laws are, why they're important, and what is their meaning. There is a chapter on self-critical systems that explain why uh, Bitcoin is a self-critical system, and this leads to this scaling variant behavior. There is a chapter on network theory explaining how power laws are very common in networks. So it's actually a very interesting book where you can learn a lot of things about physics in general, different topics that are related. That if we are right that and this is angle to understand Bitcoin is correct, that is a network, and so it's showing network properties following this overall or the overall trend that it is a power law. I think it will give you an insight not just on uh, like like a curve fitting type of tool, but on the physics behind it, right? So hopefully something that will be very useful to understand better some of our point of views on this topic. It's interesting how your background is switching back and forth, Stephen. Do you have like a he actually frozen again?
No, when it's hanging repeatedly, and when it does, it loses the background. So
The background. Okay. All right. So why don't we go ahead and start the show? You have an agenda that maybe you want to share with us, Stephen?
yes, let's hope we have some stability here.
Yeah.
Okay, it's March 4th, 2026, where I am, and it's March 5th. And next week, we're going to reach 20 million Bitcoin, only 1 million left. And people say, well, it takes 114 years to mint the next million. But in fact, it only takes 73 years to mint the next 199,999. This is the number 38 show, Physics of Bitcoin. And I'm going to talk about the residuals and the distribution of the residuals, first from the perspective of looking at the total residual history, which is about T-location scale, which is a generalized form of student's T distribution, and then break that into regimes and see how the behavior change in regimes. It's very important, and it makes a big difference in the interpretation. So that led me to look at two-stage models for the residuals. And so that's what I'm going to talk about, and some interesting findings. Okay, so the agenda first is that there's this nice slide. You shared a version of this, I think, on X, Giovanni, and I think this is a slightly different version, but it's the same, from the same source, GDP and energy per capita. I want to show some of the findings that I've made in the last few weeks about the relationship between financial conditions and z-scores, which are how far we are above or below the power law trend, and talk about the maturity measure with the Lambert W. So it's a few little interesting introductory things, and then get into the core of it, which is this T-location scale by regime, both for gold and the dollar. I'll talk about Garsh conditioning. I'll explain what that is in a moment. And then get over to the two-stage breakdown of residuals. Basically, fit a power law, you get the first stage residuals, then fit log periodic bubble and wave behavior, which is kind of intermediate scale as opposed to the longest term scale of the power law. And then you get a second stage of residuals. And then those can be modeled with volatility decay. And finally, they can be Garsh conditioned. And when you get to the end of it, you find out you have something that's more easily describable. This is a log chart, GDP per capita and energy per capita. So it's really the same GDP as a function of energy. And these things are all little squiggly lines because it's showing the track for each country over a period of about 25 years, 35 years, 33 years, as they go from 1991 to 2024. And of course, we have the developed countries in the upper right because they have the highest energy usage per capita, and then the highest GDP per capita. So up in the 100,000 kind of domain at the very top end of things, and then 100,000 kilowatt hours per capita at the very end. But you can see that on this log chart, we span 4 orders of magnitude in energy intensity almost, and we span 6 orders. No, sorry, 2 orders of magnitude in per capita income or GDP. So there's essentially a slope here that's more like 2/3. I actually ran one through chat and said, what's the slope? I think it said 0.69. But it's something like GDP grows as energy to the 2/3. Now, the market cap of Bitcoin grows somewhat superlinearly with energy as well. And it turns out that that's like in the 1 to 1.2 space. So I thought this is sort of interesting. Energy is essential to growth and to wealth. And it's also, of course, the core of Bitcoin's definition. It's created in energy, and it has this superlinear nature. It'll be interesting to pursue that in a little more detail. It's going to be a good intern project for the Scientific Bitcoin Institute. This is a chart of financial conditions versus liquidity. I published a Substack where I looked at how much was liquid. Can you hear me?
Yes, very well. Yeah, I was making a joke that we are looking for.
Can you hear me?
Yeah. Yes, I can hear you very well.
Okay.
Go ahead.
Okay, so and in that I showed that after you take out the power law and the log periodic behavior and try to explain the rest of the residuals, I found that you get more explanatory power from financial conditions than you get from liquidity. And the measures I used for financial conditions was, fortunately, it's only for the US, so it's not a perfect measure, but it comes from the Chicago Fed and it's available every week. So it's quite timely. It's called ANFCI for it adjusts for like business cycle, National Financial Conditions Index. So it's essentially a measure of marginal risk appetite and funding leverage and stress in the system. And then I used the OECD M3, which is a very broad global money supply for developed countries. And that's slow monetary aggregate, and it doesn't move that quickly. And also the policy decisions for it are made backwards looking. So they look at what happened, and then they decide to adjust interest rates and monetary policy. So you would not expect it to be that responsive. So in the lower chart, I fit log periodic plus, you can see the jaggy sort of behavior. That's as a result of adding in some weighting for the financial conditions. And it turns out that the log periodic behavior is the more intermediate term and the financial conditions the shorter term, but they have roughly overall equal weight. They're of roughly equal importance across the whole series. And there's a slight lag in here. There's a 2-week lag between the financial conditions index value and when it affects is reflected in the Bitcoin residuals, but it doesn't matter too much. Short lags all work pretty well. The upper chart then says for the given value of this financial condition index, which is marked by X right now, we're at minus 0.5 roughly. And the way it's defined is when there's more stress in the system, it's a positive number. And when there's less stress, it's in the system, it's a negative number. So you want normally to be on the negative side. And I did a regression for how much is Bitcoin above or below trend, and that's the Z-score here. And I used a TLS distribution for the residuals. And what you find is when you have a lot of stress in the system, really at like minus 0.3 and above, it's pretty flat. Certainly above 0, it's very flat, and above minus 2, it's pretty flat. And having a great deal of stress in the system, you don't expect to see very often, right? Because then the policymakers react and then relieve that stress. So then the other question is, when you have lower stress in the system, how does it fit? So I had to fit with 2 segments to get a good story. You can't really fit the whole thing with one segment. In fact, I used a sort of parabolic function. That doesn't fit that well. It's better to just break it into 2 linear segments, at least first order. And so you can do that, and it's not perfect alignment. It has an R squared of 0.44, which is actually pretty good in financial series, and that's what you're seeing. You're seeing this sort of shorter term noise that's typical of financial series. And that's the kind of slope. So where are we now? We have low stress. So in theory, we should be at a higher price, right? We should be a positive z-score up above zero. And we're not, we're more than one sigma down. Okay, and this is a measure of the maturity of Bitcoin by looking at the power law index as a function of time. So you're only looking backward in time. So I've plotted what would you have measured for the power law index K, in 2012 and 2014 and so forth. And this one is done in gold, Bitcoin versus gold. So it kind of eliminates some of that concern about dollar inflation. And what you find is that, it starts out low, but it shoots up close to 7 with the very large bubble in 2013, and then it flattens out. And actually, since 2016, it's been below 6, above 5, and it's consolidated. And right now, for Bitcoin versus gold, it's about the 5.25 power. Now, there's something called the Lambert W, which for these kinds of systems that start out exponentially, but they're self-regulating, and so they move over into bounded scaling behavior, of which a power law is a clear example of bounded scaling behavior. And then you define this relationship: W e raised to the power W is equal to X. And here you can directly take K as for X as the metrics, and you solve for that, and you get a W of 1.36. That's considered quite strong already. But there's also a rescaling process you can go through, and it has a little bit more complicated relationship. You have to pick this gamma, but you look at how, this total range that's available for K, put some limits on that. And then you find out that the W score is 1.51. That's a very strong signature of what's called Lambert maturity. Things that have those kinds of scores have locked in really nicely as, long-term scaling behavior systems. Okay, now let's look at the residuals for the T location square analysis. This is in gold. There's a power law chart of gold there. That particular one showed 5.28 because I was just using quarterly data, so it doesn't have quite this high resolution. But even with quarterly data, it's very, very clear. And then you subtract that out, and you get this distribution against that's a QR median. QR 0.5 is the power law. Subtract that out, and then you get a T location scale analysis of the residuals, and these Z values are relative to this scale parameter, which is the best fit, and that's 0.315 in the log, and that represents a factor of a little over 2 multiplicative, because 10 to the 0.3 is a factor of 2. The location is close to 0, as you would hope, and then DF nu is the degrees of freedom, and 400 is a high number. And when you high number, it means it's close to Gaussian. In fact, anything above 20, or the 20 to 50 range, is approaching Gaussian-like behavior. So that's interesting that once you remove that, here in the gold case, you get that high number that suggests Gaussian. Now, there's a reason for this, which is that the volatility, which here we measure by the scale parameter in TLS, so it's the third letter there, is falling drastically. In fact, it's falling roughly inversely with the age. So it starts out at above 0.4, and then it's below 0.1 for the last point. And all I did was I divided into 4 sections of equal duration, each about 3.75 years for this history here. And they're color-coded, and you can see the normalized Z values, where they're normalized to what the average scaling factor is for that particular quarter of the history. So this is something that you can then run Garch conditioning on, and that looks for volatility clustering. And what we've got here is we've got volatility changing across different regimes. And so that's going to give you something called a heteroscedastic illusion of fat tails. So after conditioning for this volatility clustering, all these regimes actually are approximately Gaussian. So the heavy tails are arising from conditional heteroscedasticity on two scales. One is the scale over the entire thing where the volatility is coming down very drastically, but also internally within each one, because you have correlation in the short term between volatility. And this shows the classification for this degrees of freedom new parameter. If you're in 4 to 8 range, you have fat tails, and 8 to 20, you're still moderately heavy. But the ones that gets above 20, you're getting more and more Gaussian. And 200 is indistinguishable from a normal distribution, which in our case is log normal, because everything here we're talking about log price residuals. And so the idea is that when nu is very small, you've got tail risk, you've got crises potentially, but as it gets higher and more towards log normal or numerical Gaussian, the residuals are behaving in a more stable and mature fashion. Now, this is interesting. I did a rolling metric of TLS with a 52-week window, and you find that it oscillates between high values and low values. And what I've done is I've inverted nu. So this is 1 over nu. So that means when it's 0, it's a very high number, which means it's very close to Gaussian. And when it's up around, above 0.2, then it means its values like 5 for nu, which is quite fat tails. So anything above 0.1 here is fat tails. But what we find is that we oscillate frequently and rather rapidly, and very well correlated with the known bubbles at 2013, 2017, 2021, for example, between being Gaussian and quite stable for a while, and then running into these bubbles where we have quite fat tails in the bubbles. And then, in fact, you see here, if you look at the end of 2025, you see the sudden drop that we took from October. So, that's fat tail volatility where the magnitude is significant, but the sign is in the other direction, right? So you kind of pin to 0, and you would expect that for the power law core, actually, for something that's stable.
Did you check?
Drift away from it quite violently.
Steven, can you hear me? Did you check if it has any predictive power in the sense?
Yes, I can. Yes.
I was asking you if this has any predictive power in the sense, does it precede any other indication of the presence of this bubble? Does it tell us that a bubble is coming, or can in comparison, I don't know, maybe with just deviations from the power.
I did not try to use this. I did not try to use this to predict, but instead I've been looking at using the log periodic analysis as predictive.
Okay.
Can you hear that?
Yep. Okay, I got it.
Can you? Yeah. So, but that's an interesting thing that would be worth exploring. Okay, this is still for gold, and this is just showing what the new values were before you do this Garch conditioning. And what you find is that you had a high number already for the whole distribution, but when you broke it down into quadrants, you have extremely high numbers for the first 3, but the most and there's a typo. That should say April 22 to December 25. That most recent one actually had very fat tails, 4.4. And then you can see in the next column the scale parameters, which started out at 0.46 and dropped to 0.08. And then you have, after examining for Garsh, so Garsh, generalized autoregressive conditional heteroscedasticity, is saying how volatile is the market expected to be based on prior vol and most recent shocks. And when you do the Garsh analysis, all the weight's in alpha. So it's saying everything is responding to the shock. It's not in this other beta term, which, and it's also showing that the volatility is highly persistent. It was sort of bumping up against the limits for the first 3 quadrants, but in the last interval, the half-life of that was about 1 month. The dominant evolution is the compression of scale, which we can see is quite dramatic here. The modern regime looks heavy-tailed, but then once you Garsh correct it, its degrees of freedom new parameter is raised to 231. So that's correcting for all the small scale. And it still has a very high alpha plus beta of 0.98. So the full sample is misleading because you're mixing regimes. And then even within the modern regime, you find short-term correlation between what's called innovations, which is really the next shock of price. And the shock could be a small shock or a big shock. It's just a change in price from one interval to the next. So all of this is evidence of maturity of the system, actually. And this is what the 4 regimes look like. They've been normalized. So if you look at the first 2 at the top, you find that the sigma runs up to 0.8 and 1.0 in log 10 residual units. And you look at the lower 2, it only runs up to about 0.4, 0.5 at the very peak. And it's very much suppressed for most of the most recent one, which is in the lower quadrant, right-hand quadrant. So you have structural compression, you have episodic shocks, but when you Garsh correct them, they look Gaussian. So that's in gold. And in fact, you can take the 4 Gaussians independently that those seem to exhibit. And then if you push them together with equal weights, you get the purple line. And that indeed has fat tails, right? Especially skewed to the right side. And for the first 3, the degrees of freedom new parameter was extremely high, up in the billions. So the standard deviation scale are identical. And the 4th one we adjust for what the new value was by this little formula. The scale of 0.08 gets increased to a standard deviation of 0.11. So that's how those were done. And actually you do a Monte Carlo and you get agreement here. So this is the student t-test on the mixture. And the best fit is the orange line. The blue line is what I just showed you on the previous chart for the mixture of those 4. And they're relatively close. And if you do a Monte Carlo, you get a new parameter of 7.5. If you do the fitted student t, you get a new of 7.4. So those are in good agreement as well. So summarizing the Bitcoin versus gold analysis, the structural volatility compresses dramatically. The fat tails are explained by regime mixing and volatility clustering. So you have a highly strong shock responsive system that is strongly responsive to shocks small and large. It's conditionally Gaussian, which means after you've Garsh conditioned it, it behaves Gaussian. Now, could Bitcoin dollar be different? Because Bitcoin has dollar liquidity cycles, it has spikes in interest rates, in foreign exchange rates, policy regime changes, funding stress in the system, which is the stress index, et cetera, that I showed before. So let's look at that. First, this is the same TLS Z-score analysis for Bitcoin versus dollar. And overall, it has heavy tails, 5.3 for the new, scale of 0.24 which corresponds with that new value to standard deviation in Gaussian terms of 0.3, which is a factor 2 up and down in a multiplicative ratio. And here I split it into thirds because I was using weekly data rather than daily data, so I didn't want to push it too far. But what you find is that the scale parameter dropped very steadily from 0.39 to 0.26 to 0.15 by the last third. And in standard deviations, you get what's in the final column. And also, you found that the first regime, the first third, had a very high new value, and so did the second one. And then in the last regime, just looked internally, had a 7.9, so not as heavy as the earlier overall tails, but moderately heavy tails within. So falling scale will cause inference of fat tails, or what's called this heteroscedastic illusion of fat tails. Now I did Garsh on these, and here this is in quadrants. And once you Garsh correct, everything was quite high, above 200 for each of the 4 separate quadrants and for the entire mix, except the 2018 to 2022, which was at 73, but that's still quite large relative to the 20 to 50 transition range. And all of the alpha plus betas are close to 1, except the overall is lower. We do have a shorter half-life in the 4th quadrant of 41 weeks. And in the second, somewhat shorter of 82 weeks. The others, they look like they're roughly infinite. So again, in Bitcoin versus dollar, we're seeing the effect of regime mixing and volatility clustering in the shorter term, and the heavy tails essentially disappear. And then I tried eGarsh, which adds an asymmetry test. It didn't really give a different picture. It gave a similar view of 280 to 420. Half-lives were shorter. They were gamma positive, except for the last one was gamma negative, where the down move increases volatility. But that's kind of interesting, because that says that maybe the 4th interval is reflecting institutional behavior, that there's more integration between Bitcoin and the global risk asset volatility macro system behavior, which tends to be gamma negative. That is, it's behaving a little more equity-like, because we've got the ETFs, we've got derivatives, we've got leverage. There's just a lot more games that are being played, like this, what happened with Jane Street, right, in recent months. This is leverage asymmetry when assets are used as collateral, and Bitcoin is very natural to be used as collateral because it's so liquid and it trades 24/7. This is a fit backward looking with a 1-year window of the TLS scales. And we can see they bounce around, but in general, they're getting lower. And so I'm looking at each year. What did you look like if you look back for the prior year? And that's what these dots are. And you see the 2011, 2013, 2017 bubble, the 2021 bubble, not so much. It's messy. But the overall trend is down clearly. And you can fit it with the power law. It's kind of a minus square root or inverse square root power law. And you can fit it with the reciprocal fit, and it has the form of 1 over A plus an offset of 1.7, where A is the age in years. It's not a strong R squared, but it's fine for sort of financial series, R squared of 0.34. Clearly kind of messy, but also clearly trending down. And also you can think of it as basically core and bubbles. In the core, you're below 0.1, and in the bubbles, you're above 0.2. Okay. Now, what I have done for a deeper analysis of this than what I've just shown you is develop a process for removing structural layers. We observe heavy tails. So the first thing we want to do is remove the power law, which is CSI, continuous scale invariance. The next thing we want to do is remove the discrete scale invariance, which I model with log periodic behavior, because we would expect a continuous scale invariant system to exhibit discrete scale invariance, and I've talked about this before. And then we remove the deterministic heteroscedasticity, which is really the decline of the bubble volatility, so we fit that. And then we remove the shorter term noise conditional heteroscedasticity, so that's the noise volatility decline, so we remove that. And once we do all that, we're going to find that the residuals, and this is Bitcoin measured in dollars, are close to Gaussian. So let me take you through that. So we're looking at both stage 1 and stage 2 residuals. So in stage 1, we remove the power law. We use the QR median because that gives you a better treatment of bubbles. QR is not as influenced by bubble peaks as ordinarily squares is. And then I looked at 4-mode log periodic and 2-mode, and I found that 2-mode is sufficient because it captured 50% of the movement, R squared 0.5. Whereas when I added 2 more modes, it was only 0.53. So the 2 modes are the fundamental plus a slower mode as the subharmonic that moves at half the frequency in log space terms, or log time terms. And then also, I used what I had found for the decline from the TLS for the decline of the amplitude, and I modeled as 1 over h plus 2, which is a little more conservative than the plus 1.7, but I wanted to err on conservative so that I wasn't stealing noise, from the ultimate stage 2 residuals, and being a little conservative on price projections as well. So stage 2 is we remove the log periodic as well as the power law, and then we get the residuals shown here in gray, which, look flatter, right? But also declining somewhat. And so I fit also a reciprocal decline, but it's much slower. It's a slow decline, and the actual value is 6 divided by h plus 27. So that, if you plug in 17, you get 6 over 44, and that's a number like 0.15 or something. And that is our current volatility in log 10 of price units. And, I don't know, it's log 0.2 is 1.58, log of 0.1 is 1.26. So it's something like the geometric mean of those two numbers. So it's 1.4 maybe in multiplicative terms. If you take the stage 2 residuals and put them on a QQ plot, they line up quite nicely, and that's even before Garsh conditioning. They're already fairly close to Gaussian. There's a little bit of fat tail behavior. After you condition it, that goes away. So I remove 3 structures, and I end up with Gaussian log normal noise. The long run attractor, the autopoietic spine, the power law takes out the secular drift. The discrete oscillatory structure, the bubble timing models, log periodic, where I use 2 modes, keep it fairly parsimonious there. And then volatility in both the DSI signal and the exogenous nodes are removed with 2 separate deterministic variance decay curves falling as reciprocals of age. And, this is Bitcoin maturing. So the statement here is that fat tails are largely structural regime mixing artifacts rather than intrinsic noise. And the second stage Garsh condition residuals all have nu above 200, which is quite Gaussian. And this is all consistent with 3 timescales for Bitcoin: a long-term power law, intermediate-term log periodicity waves, and those 2 are endogenous, intrinsic to Bitcoin and its structure. And then the third one is external, exogenous shocks from a variety of external influences, of which I've talked about financial conditions especially, but other macro influences, regulatory changes, news events, whatever your favorite liquidity measure is, et cetera, et cetera. So I look at Bitcoin in terms of these onion layers. And here we go to the middle of the onion first with the core power law. And that tells us that as age goes up 50%, that the price should go up a factor of 10. And then we move out to the intermediate term, the discrete scale invariance, which is the log periodic behavior. It has this characteristic lambda 2.07, which converts into an angular frequency, multiplied by the log of the age. But it tells you that the spacing between the fundamental modes of the bubbles gets longer and longer with time. And then you get contributions from a subharmonic and higher harmonics as well. But I've just modeled the two most important ones because that had almost all the energy. So this is endogenous, and you can apply a reciprocal decline to the amplitudes of those. And then finally, the short term financial conditions and all the other external macro kinds of influences, exogenous, and a longer reciprocal decline. So you've got power law intrinsic, phase timing with DSI log periodic, and then fast forcing from financial conditions, etc. And that's the model. And the next step then is to do forecasts with that. So thank you very much.
Can you leave a model up for a moment?
Yes. Which
the last graph, I want to see the final result. I wanted to comment.
This one or this one?
Just a second. Yeah. The predicted graph. Okay. Yes. And let me see. So, what is your interpretation of where we are right now?
Well, we're down by 1 sigma roughly, right? With this recovery into the 73 zone. With the QR, you're around 116,000 would be the power law trend value. And with the ordinary, if you do an ordinary squares, it's a higher value, like 127,000. If we're down by a little more than 1 sigma compared to the ordinarily squared, and just around 1 sigma compared to the other. The QR.
And, so the next peak is supposed to go all the way to 27.
Okay, well, here's in fact, if you just take the fundamental, and I'll talk about this in our next show, you would be at mid 2027, but once you include the phase, it pushes you into 2028. And in fact, the fundamental mode and the subharmonic are constructive right now. They're constructive interference. And you can see that we're starting a trend up, and we're above the zero line, right? And in fact, they're going to be constructive through the rest of the decade, through 27, 28, and 29. You'll have some flattening in 2028 once you consider phases.
Sounds interesting. Okay, we will see. It's an interesting hypothesis. Okay, thank you, Stephen. All right, so by the way, let me. So this is actually the book. I'm sorry if I plug myself, but I think it's very important tool for people to even to understand the show. It will give you a background. Uh, by the way, I'm going to have also a companion, where people can actually do some exercise, learn how to plot the power law. There will be a companion book and a companion website where people can see live charts and all kinds of different tools that are useful to understand the physics of Bitcoin. So again, if you like to pre-order it, it's where you go. Um, okay, and let me share what I wanted to present today. Okay, so I came up with a new indicator. It is actually, I'm pretty happy with it because I even tested it to do some trading. I know that many people don't like to trade Bitcoin, but I'm moving more and more towards the idea that at least a portion of your Bitcoin maybe you want to use this opportunity that we have right now, that we have all these different um, derivatives, like, for example, futures or options and so on. So it's not unthinkable, even maybe just to learn a little bit about these tools, to play with it and see if it works with you. Because, the idea of sitting on your Bitcoin is great. In the next 20 years, we are projecting at least 100 pair, that is still amazing for basically any type of investment. But in theory, if you learn how to do some of these things, to understand actually the power law as a tool to identify uh, times where we are in a bear market, in a bull market, maybe again without doing anything too risky, maybe you can actually buy only Bitcoin, you can get a little bit of a yield. And these tools should help with that. In fact, I tested it. I know that it's a little bit of cheating when you do this test because if you're trying to use something that it's supposed to use, for example, leverage or other things like that, in a time when we didn't have leverage, like few years ago, I think some form of futures were still available, but were not very much used, right? There were maybe some um, asymmetries or some um, some imbalances in the market that in the past that this tool exploits, and they will not have been available, because if there was a mature derivative market in the past, or a market at all, a derivative market at all, maybe these opportunities will have been eliminated, right? So you have to take it with a grain of salt. But it was kind of fun to see, and I double check, triple check that I didn't have anything. Like whenever you do a trading system, you have always to look for looking ahead. If you even if you have an indirect way of looking at data in the future, you're going to get some crazy results that are completely unrealistic. You can make money very quickly by knowing the future, right? But it happens when you code this kind of trading system. But I double check, triple check, ask all the different type of AI, and all of them agreed there is not. And it was giving me, if you started this at the beginning of Bitcoin history, when we started to get data, so 2010, you will have right now 800 Bitcoin. So it's also a way of showing it does pick up very well a period where we have a bearish behavior, bullish behavior, and so on. And these are indicated by the chart. So what am I doing here differently from other indicator that I developed in the past? Is still using this language of a slope, what I call the local slope or the daily slopes, um, that I want to remind everybody with logic behind that, basically we're looking at returns. So instead of looking at price or deviation, like most of what Stephen talked tonight were deviations from the power law. So we're talking about price, right? But you can also think about returns. So if you express returns as ratios, so for example, the price today over the price yesterday, um, and then you make this assumption that basically over the long term we follow a power law. Uh, then you can derive it yourself, right? It's not very difficult derivation. You're going to have something like this says, okay, the price at point two or time two is equal a, some constant, time two to the end, right? And price one at time one will be a t1 to the end. When you take the ratio, the a goes away. That is actually a good thing because we have only one parameter now, just n. That is interesting, right? So it's a way actually to describe Bitcoin behavior with one parameter, just exponent, that is interesting. And you can derive something that looks like a price chart by compounding the gains, right, over time. And these are the gains, basically. Um, and then, you test these hypotheses that these formula are correct. So it will not be perfect, right? It will be the power law plus some noise, right? And then if you have noise, then this power law behavior will be followed in average. It will not be perfect, right? We are not following this red curve perfectly, but we are oscillating around it. And so to test it, you actually plug in real value of the prices, price today over yesterday. You do this for the entire history of Bitcoin, and you, if you look at this formula that I just described, you take the log of both sides. Uh, Basically, you get the log of the returns, right, is equal to some constant that is the exponent actually times the log of the ratio of the time. So basically, if we're talking about daily slopes, we're talking about t, that is the age of a system, in the denominator, right? And the numerator, you have t plus one over t. And this quantity, you can see, first of all, is deterministic because it only depends on the age of a system, and that is a number that we know, right? And we can calculate. We can say, okay, how many days today from the birth of Bitcoin, and you can see this number tends to go to one, right? Because as t becomes very very large, t plus one over t is almost one. But um, right now it's not quite one. So you, like I say, you take the log of this quantity, and if you divide the log of the returns by this quantity, this deterministic quantity, you get an exponent. You get the exponent, this n, right? And because we are not moving along the power law in a perfect fashion, we're not following the red curve, this n is a stochastic behavior. So it follows a distribution, right? And we describe these distributions, like, for example, I say it's at the location scale. I don't remember by heart. I can look at the values. Maybe next time we can look at that because maybe I can do this regime analysis that you did, Steve, by looking at how big if you apply at the location scale, it's going to have three parameters, right? It's going to have a average mu, it's going to have a sigma, that is how fat the distribution is, and then the tail, how big the tail is. So I plot nu, that is the tail parameter, on a rolling window. I don't remember by heart the value, but I'm curious. I will go back and see if we can identify the different regime that you talked about. Um, but it's possible. It will be interesting to see if it is different from what we get from the residuals, right? We're talking about the returns now. It's possible the returns are much more, the tails are much bigger than for the price itself. So what is different? I have already an indicator that shows the mu of this parameter, and then adds a sigma, right, on both directions. I showed this indicator in the past. It's one of the indicators that are available. If you want to join the Patreon program that we created for, where you can access all these indicators. We have, like, I think right now close to 16. And at a certain point, by the way, all these indicators will become, I'm thinking about assigning the ownership to the Scientific Bitcoin Institute. So if you become a member of the institute and you support our cause, you will get, if you subscribe for a 1 year membership or something, you will get all kinds of different benefits, like a newsletter or kind of things like that. And also you will have access to the indicators. And this will be one of them. So this one is different because from just calculating mu will be the average, right? That average, by the way, it's interesting, is 5.9, right? It should be, if we follow the power law, then we should get that n, the exponent of daily slopes, in average is n. That makes sense. But it can go all the way to 500 or minus 500, very large deviations from the value of 5.9, both negative or positive. And that is when we go up or we go down, right? So this one is interesting because I'm taking mu and then dividing it by sigma. So it's a kind of signal to noise ratio, because mu is the signal, the average value, and I'm dividing by the sigma. Now, it's kind of similar to kind of almost like a Sharpie ratio, but it's calculated on these slopes, right? And then you can identify different regimes that indicate like a bearish behavior. And so, for example, the trading strategy say during this bearish behavior, you should be all cash. It works, over the long term. You don't have to do, maybe you can rebalance during this bearish behavior, right? You can get a little bit of cash and not being all in Bitcoin. And then the green regions are the most bullish behavior when we have a transitions, that are the blue ones. So the 3 different regions. The green part in this strategy, you get, if you want to use futures, for example, with very, very small leverage, like, for example, 1.5 or just a little bit above 1, then you can, over the long term, this strategy really works. And it's supposed to multiply by a big factor your Bitcoins. Not everybody needs to do it, but it's an interesting result. So it's even as a test of how well you can pick up this bullish behavior or this bearish behavior from Bitcoin. So a signal to noise indicator based on the slope. And then there is like a little table. We are not yet, according to this indicator, out of the bearish region. We are almost there. It is interesting. So you get all these interesting values, right? It tells you the z-score of this signal to noise, the current mu. Right now we are minus 8.7, over a certain window. The leverage that is suggested, and so on. So it's an interesting indicator to use. So, and if you are in the Patreon program, it will be available in the next few weeks. Okay. Do you have any questions about this, Stephen? This indicator and what it does? Can you hear me?
No. I can, yes.
Okay.
No questions at this point.
Okay. Yeah. Good. All right. And then we can see if we have any questions from the audience. She says, I never caught the live. I'm glad that you were able to join this time. Thank you so much. Okay. Then we have this question. Are we chasing liquidity near 75 and 55K cycle, or then we turn up for the next cycle? I see the power law holding strong, but wondering about your thoughts on the pace of the 4-year cycle. What do you have to say about that, Stephen?
The 4-year cycle is a myth. Let me show you a slide. Okay. Okay. Let me go full screen with that. Okay. So this plots the residuals after you take out a power law as a function of age. And then it fits to that a Fourier transform in log time, log age. And it finds a fundamental parameter that's a little over 2.07. And that's a very common value in physical systems. There are a lot of systems that exhibit this kind of discrete scale invariance with parameters of around 2. So it's not unusual that it would take that value. And so what it's saying is that between the peaks are stretching out by roughly a factor of 2, further and further apart. So the red vertical lines mark the first 3, and those are the bubbles in 2011, 2013, and 2017. There's a green one, and that's the subharmonic, and that lines up with a little bubble that partially developed in 2019. There's some blue lines, which are the first harmonic, so those are faster, and they happen geometrically in between. So a little closer, if you have a pair of red lines, it'll be a little closer to the first one because it's log time again. And they don't really line up with too much, although the third one lines up with the right shoulder of the 2021 peak. And then the next one for the fundamental is the next red line. It's off in the future at around age 18.5. I've done this in gold. I've done this in dollars, and they give the same answer. I've also used wavelets as well as Fourier transform, and those are around the 2.0 to 2.1 range. And then just from the raw timing, you get the same answer. And so the result is that, what happened to my slide? Go to a different one. Well, it died. But the result is that the 4-year cycle ignores 2011 and it fails on 2025. Whereas this one explains 2011 and it also explains 2025. The dog didn't bark. We didn't have, we had a local peak, but it didn't go that much above the power law. We didn't have a real significant bubble. So that's kind of the thumbnail sketch of the log timing, discrete scale invariance, or log periodic timing. And I don't think there ever was a 4-year cycle. And we ignored the 2011. And so we based it on just 3 bubbles, 2013, 2017, 2021. Well, that's only 2 numbers, right? That's only 2 intervals. That's not enough to do statistics on. So I don't think there was ever proof of a 4-year cycle.
Okay, that is good. Yeah, and these are kind of follows through. I I think this is what he means, a log-log relationship. Probably you mean that this is also a scale invariant process. What is interesting is something that I want to explore and understand myself more. Um, these log periodic processes are actually power laws, where the exponent, right? You know that what a power law means. It means there is a relationship between y and x, where x is a power, to the n. But imagine now for the people that took some um, advanced math, right? You know the concept of a complex number, n is a complex number, and in that case, when you have this log periodic oscillation, usually complex, we can, for example, if you have an exponential and you use a complex, um, the argument of a exponential is complex, then you get also that it's an oscillation, right? So probably something similar to that. Um, but I I don't. Do you understand the intuition beyond that, Stephen? The relationship between, I guess, is probably something similar, right? Where you get the sine and cosine being the real and imaginary part of a complex number. Um, is this your understanding, Stephen? Stephen has had some problem with connectivity. Do you understand my
Yeah,
observation?
yes, yes, and I agree. I mean, that's what we're seeing. We're seeing that the real part manifests as the power law, and the complex part manifests as this, log periodic scaling.
Hmm. Yeah. Okay. Let's see the next question. We have this one. Hi, and thanks for your informative presentations. What will need to happen for the power law model to be invalidated? Can it ever be invalidated or just refuted? Do you want to answer? I have some things to say about that, but go ahead first, maybe.
I just froze.
Yeah, but we can hear you. So,
Oh, okay.
yeah.
There I am. All right. Well, so in physics, we have this idea of infrared and ultraviolet regime. So we have these laws, and they may be power laws, and they may extend over many, many orders of magnitude. And we know, gravity and electromagnetism do that, but there are always some limits. For gravity, we approximate things with point masses, and things are not perfect spheres, right? So they're higher modes for the gravitational attraction and so forth. But also, you get some extreme limits. And in fact, we do not know if general relativity works uh, or is demonstrated if you have an acceleration that is less than the speed of light divided by the age of the universe. That's we haven't been able to probe that well experimentally, and it gets into the discussion of dark matter and even dark energy. So you have limits, and for us, the obvious limit is global wealth, and then behind that is the limit of the global monetary system. And global wealth is approaching 1 quadrillion, and 1,000 trillion. It's maybe 900 trillion, something like that. And the global money supply is something like 120 trillion. So that's 2 orders of magnitude almost above where Bitcoin is. So there's a lot of room to run. I do check this from time to time with a function that's called the Weibull function. And it's a power law until it reaches a knee. And, in my latest check earlier this year, I found that there's no departure. In other words, the Weibull function with a curve has no better statistics than a pure power law. So you take the simpler one until it isn't.
Yeah. So yeah, okay. So we can develop many tests. So for example, this idea of slopes that I develop, it's a very good test because it's actually looking not just at the trend itself that can be spurious. Many times when you have some spurious trend, if you take the derivative of a trend, then it disappears. And the fact that actually we have a confirmation of a trend by looking at the derivative, so that is a change, so the returns basically, how much the price change from day to day, it's a confirmation that, like many confirmation, because we at this point we did it so many times with different tests with different things, that everybody that knows a little bit of math has no doubt that the Bitcoin behaves like a power law over the long term. But this language of slopes is also very sensitive, and so one of the things you can do, because it's not just a question of, the regression line, it's also a question of the stochastic property, right? So it seems that there are two components. There is this overall trend that is deterministic. Deterministic means simply that is given, if you give me a number, I tell you what the value is, right? So in this case, time, it's just a function of time. And then there is a probabilistic aspect, a stochastic aspect, that are the fluctuation around the power law. And when you renormalize the returns, like I explained, then this quantity is stable. It's stable in mu, is stable in u, that is how how big the tails are, and sigma, how large, or how fat or slim the distribution is. So you can look at all these three parameters and monitor them and see how stable they are. And in fact, you can compare, right? You can calculate how these values distribute over time in a rolling window. And there are tools, um, there are many different ways of testing if a distribution is consistent over time. And I have done several of these tests. And if we deviated, not just in mu, but also in some of the other parameters, we will see a change in this test, right? The test will tell us little by little we are deviating away from the power law. And so far that is not happened. Actually, it's showing that we have consistency, right? Even when we jump down, right? Because it doesn't matter from a point of view um, of the returns. If we change where we are relatively to the general trend, but we still follow in a parallel line, that seems what is happening, right? We change almost like we go to the lower level, right? But we are still following the power law in terms of trend. The structure is the same. Um, and so also that means that eventually we are going to mean return, right, to the middle ground. So right now, we have these sophisticated tests that go beyond just regression, for example. Regression also can tell us, right, if R square continue to get larger and larger with time and stabilize, etc., or the exponent stabilize. People do tests like that. They're doing tests like this all the time. Me, Steven, and other people that study the power law, and they post online all the time. So you can do a test on the stability of the exponent. It seems to become more stable with time. You can do a test on the R square, how good the fitting it is. When you use a regression method, you can use this studying of the distribution of the returns, a bunch of studies, like basically going to the doctor, right? You don't want to do just one test. You want to do x-rays, you want to do a blood test, you want to do a bunch of different things, and you get a picture of what is going on. All the tests we are doing right now, they are confirming that the power law, if anything, is becoming stronger with time instead of becoming weaker. So, but this is a good question. So, if we deviated from the power law, we will be able, first of all, I think you will be able to see it with your eye. I know that sounds silly, but in my training as a physicist, my advisor always told me, when you want to get a good idea about the data, first start with your eyes, try to get a feeling, an intuitive feeling of the data. So you will be able to see it with your eyes. But all these sophisticated tests will also tell us something is different. But it's also the point of doing modeling, because even when things are going wrong, right, I'm sure there will be some people will celebrate if we don't follow anymore the power law. For what I saw people celebrating the gold power law bottom being violated, like wow, like why? Because now, first of all, we never say there was a bottom there because there is a bottom simply because for a long time the gold was stable relatively to USD. It was kind of flat, right? And so because there is a bottom with USD, there was also a bottom with gold. But if gold moves relatively to USD and it goes up by a factor of few, that support line is so um, it's like it's strange because we are usually say with the power law it's a scaling phenomena. So only factor of 10 matter, right? But it's strange that we have this support level that is only a factor of 2 relatively, and it's holding. So it's really sensitive, right? When people say that the power law is not sensitive, it is very sensitive because we have, for example, that floor, but we never say that it's valid for gold for several reasons. For example, if there are some indication that the floor has to do with the cost of production of Bitcoin, and the cost of production, people don't pay electricity using gold bars. They use the dollar. So, but it's still cool that if you focus on changes of order of magnitude, the power law in gold is still valid. So yeah, there are many different tests that we can do, and so far everything indicates, if anything, the power law is becoming stronger, not weaker. And these tests are pretty sensitive. Uh, what do you have anything to say about these other comments?
No, that's good. Yeah.
And you agree, right, with power law,
Yeah,
if anything?
sure. I
Same
mean, I
case.
just showed you how the index changes with
Yeah,
time and how it flattens out, and there isn't
exactly.
any evidence for deviation at this point. And so we
Yeah,
have to assume that what has been true will continue to be true. And we wouldn't really know until the age is increased, 50% from here.
yeah, exactly. Yeah, because in the end, though, even if these tests are pretty sensitive, remember the power law, it's an order of magnitude phenomenon, right? We're talking about a scaling behavior. So we need to see what happens in the next several years. Bitcoin is supposed to have another test of this scaling, that is basically when we go from kind of the order of 100,000 where we are now to the order of a million, right? If we do it in the time frame that the power law suggests, that is basically 8 years from now, then that will be a big, huge test, right? If we take longer time, shorter time, by a big factor, I will say, we can even calculate what will indicate that we are not following the power law. But that is how you measure it, right? You will need to wait that kind of time. Because in the past, no, because in the past, the first year, for example, you had to wait another year to get a factor of 65, so almost 2 order of magnitude, right? So you could test this power law idea very quickly in the first few years. Now, but there was also these huge big bubbles that kind of confounded things, right? So people didn't see the power law until basically was not clear until 2018, and by then we went up several order of magnitude. But yeah, the next test will be really strong test will be, are we going to take 8 years to get the next million, right? The next factor of 10, so a million. So I think that will be the most, let's say, intuitive test. Um, anyway, what do you think? I wrote actually a post. I answer all the points. It goes more or less in this way. Um, it's not fungible. Okay, now it is fungible. I don't know why he will say that. People are using it. I mean, maybe it's not the main use, but it's very fungible. You can buy stuff with Bitcoin all the time, and there are more and more initiative, right? For example, Square now does that, right? People can pay for services on using Square online, and it's integrated with Bitcoin. Um, I I went in Europe. I went to different conferences. I did different things using Bitcoin. Now that is not a point at all. The fact that it lacks privacy, it's more private than other things, right? But that is not the main purpose, right? Um, sure, maybe cash is private, more private than Bitcoin, but it has also problems, right? So I don't see it as a. Um, we almost never say uh, Bitcoin is a great thing because it's private, right? We say that is they cannot steal it from you, right? But it's very difficult for a government to have access to it. Uh, Maybe they can even say, "Oh, we see some transaction that was associated with you, maybe, right? You know, many Bitcoiners lost all their Bitcoins in a boat accident, right? That is the final point. It, like, it lives in your head if you memorize the seed words, right? The passphrase. So that is the main point. Now that is private. Um, okay. Um, and then the central banks, sure, central banks maybe right now they are resisting because is what actually it's saying. I don't know. It's kind of a oxymoron, of course, right? But even there, um, is not true, right? Because, for example, El Salvador buys is a government and they buy Bitcoin. Bhutan has a government program where they get Bitcoin. So yeah, I don't see why that is a big deal. We are trying to give less power to central banks through Bitcoin. So of course, they are not interested in buying Bitcoin, at least now. I think that will happen, because it's a question of scale, right? When Bitcoin will reach a scale in terms of it's basically kind of similar to what we were discussing in the beginning with GDPs and things like that. When Bitcoin will reach a market cap that is equivalent to the GDP of nations, I think we will see very interesting thing happening. Possibly large nation actually adopting Bitcoin as the standard. Some big event. And this actually maybe that is the end of the power law because we will have a phase transition at that time. Um, So, but yeah, I don't see why that is problematic. Anyway, but do you have any comment of this? Have you seen
I
Dalia?
have a comment on the central banks. Yeah, I couldn't find the tweet where I responded to four of the points, but on the central bank comment, there is no reason for central banks to hold Bitcoin. If a nation wants to hold Bitcoin, it's better if they hold it in their treasury.
Yeah,
The central banks are the source of the problem that Bitcoin was trying to solve or is looking to solve. It's an alternative system. Now, I think some central banks will end
I
up
don't want to
holding
say they are
Bitcoin,
the
but
enemy, but for sure,
I prefer,
yeah,
as an American, that it be held by the Treasury Department. And in fact, that's what's happened with the Strategic Bitcoin Reserve.
mhm.
It's held by the Department of the Treasury, and that's the way it should be. And in fact, the central bank, the Fed, does not own the gold supply. That's owned by the Treasury. And that's the way it should be with any Bitcoin in the Strategic Bitcoin Reserve.
Yeah. Okay. Let's see. Do we have any other questions? Something about the jump? Uh, Jokingly, maybe Jane Street is, very afraid of lawsuits right now, and they exit the room. Maybe I don't know. It could be at least partially true or whatever else.
They're being sued. There's rumors of an SEC investigation, so that may have, and they have not been active. So just the fact that they have not been as active apparently has taken off some downward pressure. But I think that in the past couple of days, the two most important announcements were the Kraken license with the Fed and the announcement of Morgan Stanley of an ETF. So we have a couple of news events, plus the backdrop of the ISM came in strong, which helped stocks and helped risk on assets. So that's positive for Bitcoin as well. I don't think it has to do with the harmonic phase, which happens in a slower pace. It's a more gradual.
Yeah, exactly. But in general, look, guys, if there is one thing that you want to learn from what we are trying to show here, that yes, there are these jumps up and down, there is volatility, etc. What really matters is this long term, right? And maybe these bubbles, if they are log periodic or periodic, are also a big component. We are used to these changes of 20, 30, 40, 50%, right? They're happening, and they are part of Bitcoin story that makes it still very interesting as an asset, you know, and maybe even opportunities, uh, because, at a minimum, you can buy cheaper, right? When we have this big correction, if you do DCA. So, yeah, you can always go back and find an excuse, right? You can say, "Oh, this happened because of that," but it's not really what is interesting to us, right? We are more interested in this long-term trajectory, and that is so unique to Bitcoin. I just came from a conference. It's one of the largest investment conference. It was all the usual suspect, BlackRock, Fidelity, and hundreds of other firms that do all kind of management of funds. And I was there, I was a advisor for Blockstream Capital Partners, and people were coming to our booth and they wanted to know, one of the projects that we are doing is this long-term power law, type of investment and trading, where it's not just DCA, it's also doing a little bit of leverage, kind of what I described, but a little bit more conservative. Uh, but there were all these long-term projections because they were based on the power law. And when we were discussing that with some of the people, some people knew about Bitcoin and this proposition that yes, there is like a trajectory. Sailors, for example, has his own model, where Bitcoin is going to be. But we live a kind of in a bubble, right? In an information bubble, because a lot of these people didn't even think about Bitcoin like that. I don't know, they like the volatility of Bitcoin, but the moment that you're telling them that there is a long-term trajectory, they were like making faces. You could see that they were not super convinced about that. In particular, if you tell them Bitcoin is going to be under pair in the next 20 years, yeah. And so it's an asymmetric information that we have. Now, there is no guarantee, but Bitcoin has done this for the last 16 years, right? It's not guaranteed that it's going to do it for the next 20 years. There are many challenges ahead because, in particular, because we are talking about now billions and maybe even trillions of dollars, right? Actually coming in the Bitcoin economy. But Bitcoin can do it. Gold cannot, right? Gold cannot go another factor of 10. Maybe that is the most that it can do. Another factor of 10. Gold, I think it cannot, even that will be very difficult because, for example, I was told, right? I think I was having this discussion with a lawyer. He was saying, there are more and more news of people becoming grave robbers because they're looking for gold. They're looking like in Italy. I mean, I don't know if they do it here in the United States, but they bury people with their gold ring, right? Their wedding bands. And now there are people actually digging and looking for that gold. Can you imagine? Because once, or my nephew, for example, my nephew left Italy and he went to Australia to work for a gold mine because there are all these announcements about looking for miners and incredible pays. People will find ways of digging more and more gold that will crash the price once it start to go to crazy values. Even factor of 2 and 3 will make a very difficult way of extracting gold commercially valuable. And when that happens, when the value goes down, you cannot do it with Bitcoin, right? Because the cap is uh, limited, right? So you cannot do that with Bitcoin, and Bitcoin has room to grow, so it can do this under pair. Gold cannot do it. Probably stocks cannot do that, right? Uh, if Bitcoin goes up by a factor of 100, that will have the same market cap of almost all the real estate in the world. It is kind of crazy, but if there is one thing can do that, it's Bitcoin. Almost no other asset can do that. Okay, maybe we can take one more question. Oh, okay, we have a couple of them. The quantum question. Any update on the quantum question? Maybe we should have another show soon because, by the way, everybody watch it. So remember, these have a number, these episodes, right? We put the number in the YouTube channel. For example, if you go to the YouTube channel, go to, I memorize that, Stephen. Stephen made a fantastic presentation about quantum computing related to Bitcoin in episode number 5. So go back to episode number 5 and watch that episode if you want to understand. Because I don't know any other presentation that was made by a Bitcoiner and a physicist. So you have both, right? It is so unique. And the physicist that actually worked on these kind of issues, that is Stephen. But maybe it's a good idea to, given there are some development, etc., to have an update in an upcoming episode if you feel like.
Yeah, we could do that. Nothing's changed really fundamentally. I've been tracking, I've not practiced in quantum computing, but I've been tracking it now for a couple of decades because of my background in supercomputing. So it's another way of doing supercomputing, if you will. And, there's nothing that's really quantitatively changed. In terms of the scaling on the physical side, we're only at a few logical qubits. We're at the sort of 1,000 physical qubits, but we can only get a few logical qubits out of that because of the noise level in the systems. I do, get updates on these things, and so I continue to kind of track it, at the broad level. There was an interesting paper published saying, well, maybe you don't need 1 million qubits with Shor's algorithm. Maybe you can do it with 100,000. But there were also a lot of other kind of strong assumptions that were made in that one. So it's not fully accepted. So you need hundreds of thousands, maybe more than 1 million physical qubits in order to get enough logical qubits. And we're at 1,000. And so that's a long way to go. And then we already have proven post-quantum, key and distribution algorithms that are approved at the National Institute of Standards and Technologies. There's several different ones. And so those can be used for quantum safe wallets. They're a little more expensive computationally. So, that's some question as to when you want to start using them. There's certain different kinds of addresses. But if you don't have an old address and if you're not using Taproot, and there's a proposal to fix that one actually, then you're not exposed until you move your coins. So somebody would have to identify yours and go after yours during the, 6 confirmations. In the long run, the hashing is not at risk. That's a different algorithm. Shor's algorithm is the one that goes after the public keys and tries to figure out the private keys. That's where the risk lies, and you'll solve that with quantum safe wallets. And be careful about how you move your coins. They're the Satoshi coins, which will get targeted at some point, and then they will be a funding source for quantum computing research.
Exactly. Anyway, yeah, and probably at a certain point, the institute will actually have a report that people can download, and we can keep this report update and let everybody know. It will be for sure one of the things that the institute will work on, maybe even working with experts in quantum computing because both of us understand the basic ideas. But if we had actually somebody that works in the field, right, in these things, people tend to specialize. Um, so that would be actually great. And it's one of the things that we want to do. And maybe even having a team that is working on solution, or maybe the institute will sponsor people that are interested in finding solutions. So this to tell you that we want to make the institute a resource, right, for the community. It's going to be the place where anything that relates to Bitcoin, and I know there are similar ones, but I don't think there is one that focus on science and using science to improve Bitcoin, understanding Bitcoin scientifically. I think we have a very unique approach. And my understanding of science is that almost anything important in life, useful, has been created by science. Medicine, the computers we are using, and so on. Right. So a scientific approach to problems, and engineering approach to problem is what in the end really gives us real results. So eventually there will be donation buttons, in the website. So if you want to donate or be a member, like there will be membership, so you can help actually having people working on this field. It's not just us. We will open scholarships for PhD students. Sponsor different groups. So there is a cryptography group, for example, in Torino, that it's very interesting in Bitcoin, and it will be one of our first sponsor programs. We are going to work with them and have money for them to actually think about some of these problems. Okay, let's take this last question, and then I think it's a good place where to end the show. Is it possible to have a incline of Bitcoin power law change by the addition of some unforeseen variable? I'm speaking of a scenario where all quantile shifts up. So I can answer a little bit, and then maybe Stephen can add. The entire point of these power laws is that they are pretty stable, right? Uh, is Once you establish that n is a characteristic of a system. So unless something radical happens to the system, that n tends to stabilize. And we have data right now. It is exactly what is happening, right? Probably was stable from the beginning. It's just that the presence of these big, huge bubbles confounded the calculation of n. But now, with more and more data, the bubbles are becoming something that are kind of a correction, to this general trend. And so the N is becoming more stable. It's not unthinkable that there are regime shifts, like something happens that changing doesn't change radically the scaling behavior, but maybe it changes somehow the speed of a scaling. That can happen, and it will look like, you have a power law, and then there is another power law that has a different slope, right? It can be tight, can be a steeper slope, or can be less steep. We have right now a power of 6. That is fast, right? It's very fast. In fact, it's surprisingly fast. There are very few power laws in nature that have such higher power. They tend to be usually smaller than that. Um, so if you're looking for something that goes faster, we are already going faster. The problem is, after 16 years, it looks like we are slowing down simply because what is involved, right? We are not talking about market cap of few hundred million, or we are talking about market caps of trillions, right? So anything that happens at that level, it does take time. It needs to take decades, right, before you have another order of magnitude change. So, and that you really cannot really change that too much, right? We are at that point where the market cap of Bitcoin has that kind of size. So I will be very surprised that is actually things are going faster. But these are some of the things that we are monitoring and trying to understand. The general idea that usually these processes are very stable over time. But maybe Stephen has something to say about that.
The reason why the system manifests as a power law is a couple of things. One, of course, is it's based on a network. And we know from Metcalfe's law that networks manifest value that roughly is a square of the growth in the network. Now, the growth of the network is observed to be a power law. We couldn't say from first principles that it would have to be until you think about the way viruses spread. And so Bitcoin has spread like a virus, and those manifest power laws. So we've got two power laws multiplying together, if you will, and that's why we're so steep. We've got a cube power law for the network growth. We've got a square power law for the value. And why? Because it's imposed with a strict supply cap. All of the rules of Bitcoin are defined in the Nakamoto consensus in what we call an autopoietic fashion, which means that it self-creates and self-controls and self-manages. And when you have systems that self-create, control, and manage, they tend to manifest power law behavior. And when they do, it happens because of the way the rules are set up. So the rules of the system, the hashing rules, the very critical difficulty adjustment, the halvings, the completely firm supply cap, and so forth, tend to enforce the nature of the power law behavior, and those rules aren't changing. So why should the power law index change? Perhaps because the network can't grow as fast. And right now, we observe that the addresses are flattening out, but that's being made up by the institutional participation. So the institutions are there as custodians holding Bitcoin for their clients, whether they be shareholders, of master strategy, or whether they be ETFs and so forth. And you find that the balances of those are growing as a power law, steep enough to support what we saw in the address growth when we were mostly retail. So I don't see anything that lifts it because it is so steep, because the rules and the nature set in from the beginning, and that's why it locked into something that's been very, very stable. You can imagine runaway scenarios where there's a scramble, right? Treasury companies or governments or something. That's going to cause bubbles, but big bubbles mean the price shoots up and people get priced out of the market, right? So they just can't participate, and other participants say, I'm going to cash in. And this has been demonstrated time and time. Sornet analyzed, and others have analyzed, that the deep pockets, the whales, are the smart money, and they tend to trim their holdings when the bubbles get high, and then they buy back in when they crash. And the middle layer and the retail don't. They do the wrong thing. They're not the smart money. They're the dumb money. So there's a self-correction in human behavior when things overshoot. Exponentials are inherently unstable. So an attempt to shift the regime really is just trying to impose an exponential on top. And that is unstable. That can be modeled with log periodic, not the same as the bubbles that stretch out in time, but within a given bubble, the waves that get closer and closer and then crash.
Yeah. Okay. Good. I think we had a very nice show. We covered a lot of interesting topics, and we will be here next week. So thank you so much, guys.
Thanks, everyone.
Bye, everybody.